We're now going to move to Michael Johnson, California Department of Transportation.
Thank you, Karen, and thank all of you. I somehow drew the short straw of the anchor leg here, and I think it's because I had more slides than anybody else. So I'm going to come at this from a very different perspective. I'm an engineer. I'm not an IT professional, although I use IT and I use data quite a bit. My job within the California Department of Transportation is to lead our implementation of asset management statewide. What that means is that we are looking at evaluating all the things that need to be done on the state highway system, prioritizing the projects that we do by location, by asset, and by need, and developing a program that's approximately $4.5 billion a year in construction value. When I talk to people about my job, they don't talk about data. What they talk about is, this is what people think about when they think about transportation. They want to tell me about the congestion that they had or the accident that caused them to be delayed. And while there's many aspects of transportation, I think there's many aspects that are taken for granted. For example, I don't think people typically come to the approach of a bridge and think about whether they're going to get to the other side. They assume that that's going to happen. And we assume that we're going to provide that to you. But travel time is one of those things that you get an expectation for. It takes me this long to get from work to home or home to work. And if anything disrupts that time, people get very aggravated. Next slide, please. Oh, I'm sorry. So that's fine. So when we think about traffic and we think about causes of traffic, I'll give you a couple statistics. 39 million people live in California. Of those 39 million, that's all ages, we have 34 million registered vehicles. That means the people of driving age are typically owning more than one vehicle. And that's kind of a California-centric type of statistic. When you think about commutes and people driving from home to work, about 73% of those trips are done with one person in the car. So you've got a lot of people driving by themselves on a system that hasn't substantially expanded since the early 70s, and you get congestion. So from a Department of Transportation standpoint, we look at how do we utilize data to help manage that system and get the most possible efficiency that we can out of the real estate that we have available. Because in many areas, there's homes and businesses built up on both sides of the freeway, and expansion is really not an option. In addition, expansion is not really heavily utilized. It's utilized during peak hours, but it's underutilized in most other times of the day. And in general, expansion can lead to land use policies that allow people to live further and further away from their work, and that exacerbates your congestion problem. Well, this isn't really a new problem. As you can see, this photo that's showing on the slide screen is then Governor Ronald Reagan in our Los Angeles Traffic Management Center. And I had to include this because he's proudly standing in front of a screen that looks like it came out of the 60s of the one video camera that we had on the highway system in Los Angeles at the time. And behind him is a map that actually has physical light bulbs that would turn on and off to indicate a problem. Advance, please. When you look at our modern traffic management center in the Los Angeles area, the map on the lower left, all those little purple squares are showing closed caption television cameras, and they're all being monitored in many screens within the traffic management center, along with travel time information. And that travel time information is in part being driven off of sensors that are in the highway. So when you drive over them, we can figure out from that how fast traffic is moving, and we can monitor that. We then can use message signs on the freeway to convey information about things such as accidents or expected travel times, and that helps to minimize the aggravation of travel. There's other technologies that we can use for the same purpose. We can use Bluetooth readers that will ping cell phones as they drive by, and then ping them later down the road, and from that we can determine how fast people are traveling. We also have entered into partnerships with companies like Waze. Someone mentioned Waze earlier, and we can share data between Waze and Caltrans so that we can start using crowdsourcing information to better manage the operation of the system. These centers here that are shown on the screen are jointly managed between Caltrans, regional transportation agencies, and the California Highway Patrol. And one of the things that they do is when they observe accidents or disabled vehicles, they will dispatch free freeway service to you. And it's paid for out of transportation funds. And that you might think, if you ever experienced this, wow, these people came up on me really quickly. It's because someone was monitoring the freeway. They saw you had a disabled vehicle, and while they want to help you, their job is primarily to get you out of the freeway, to get you out of a place where you're not, to get you to a place where you're not causing congestion. So when we look at all of this, we see, wow, there's ways that we're using sensors now and we're able to communicate with the system operators, but there's a much more promising future. Next slide. So in the transportation sector, we are literally on the cusp of a significant transportation change. And this change is referred to as autonomous vehicles or sometimes connected vehicles. And it doesn't mean they're physically connected, they're connected to each other by computer and radio signal. So an autonomous vehicle, you've probably heard in the news, can essentially drive itself. There's sophisticated algorithms and maps and vehicles that include radar, they include LiDAR sensors, they include radio communication, and in effect, the car is making decisions as it's moving down the road based on what it sees. So why is this a game changer for transportation, and how does this bring us into the data realm that we're talking about? It's a game changer because connected vehicles can travel much closer together because they don't have the disadvantage of human reaction time. They can also travel closer together side to side. So if you repurpose your existing footprint of your highway, you could conceivably get almost 3 times the number of volume through the same footprint. That would mean a substantial reduction, if not an elimination, of congestion as we know it today. On top of that, autonomous and connected vehicles have the ability to dramatically reduce fatalities and injuries because they can react so much faster than the human can. They don't ever go into a state of unattentiveness. They don't ever drive impaired, and these things that lead to a lot of accidents and fatalities on the highway system. So when we think about the highway system in California, we have about 30,000 fatalities a year. If we can reduce that in any substantial way, that's a game changer. In fact, I think that when we look at fatalities in California, something on the order of 95% of them are in part caused by human error. And if you can eliminate that component, you can understand why we're so excited about autonomous and connected vehicles. So, when we talk about this, and I'm not an autonomous vehicle expert, but people will say, well, how far down the road is this? There are 30 companies in California that are authorized to test autonomous vehicles on the highways today. This is a real thing. So in this model, vehicles can communicate to each other, but vehicles can also communicate to the infrastructure. And so as a Department of Transportation, we're looking at, well, what do we need to do to the highway to facilitate this new wave of transportation? Because there are major safety benefits and major mobility benefits for the people of California. So with all of this coming, next slide, I'll just conclude with a couple of things that we think about. How do we as a Department of Transportation take advantage of this technology? How do we use this data? There are things that when we talk to our partners that are in the business of developing these algorithms and these vehicles, they have some challenges. Construction closures are challenges because these cars look at lane lines to decide where to travel. So if you put a temporary closure in, that can be a problem. If your lane stripings fade, that can be a challenge for these vehicles. How do we handle a mix of autonomous and non-autonomous vehicles within the highway system? That's another big challenge. And right now there's various technologies that are competing, and who the winner is going to be is unclear. So there's a lot of things going forward. We got to monitor it all. And lastly, we still have to think about the safety of the most vulnerable users, pedestrians and bicyclists, because they can be on the highway very quickly, and whether these systems can react to that is something that is yet to be proven. So I will conclude with that, with this forward look, and hopefully bring home the anchor of the team here.
Thank you.